All right, and questions 1 through 4 talk about writing an equation of a line. And there's generally 3 formats. There's slope-intercept, which is not my preference, but that is y equals mx plus b. There will be a couple times today where you are specifically asked for slope-intercept, so you need to use slope-intercept. There is point-slope, which I'm much more fond of. It's kind of like radians, and that higher mathematics generally prefers point-slope. It's a little more versatile, and it's actually easier. Because for slope-intercept, you actually have to find the y-intercept, and usually that takes some work. So if you got a point, that's just more convenient. And then there's something called general form, which has very, very limited use. So we won't even talk about it today. Okay, so questions 1 and 4 kind of look the same. They both give you 2 points. So regardless if you need slope-intercept or point-slope, you're going to need the slope. So how can you find the slope given 2 points? Well, I guess you could graph them, plot those points, count rise over run, and that would be one way to do it as long as you count carefully. But most people are going to prefer the slope formula because you simply subtract the x values over subtract the y values in the same pattern. And that's a lot quicker than making a graph and plotting and counting rise over run. So I would recommend that you remember the slope formula if you don't know it. And so I'm going to go with point slope anytime I can, unless it specifically says otherwise. So point slope, m is your slope, of course. And you just plug in any point you have into x1, y1. So I'm going to just use this point. Plug in x1, y1, and the only thing I would change is I don't really like minus and negative. I'd change that to a plus. If for some reason you'd rather do slope-intercept, more power to you, as long as you're getting it correct. Now, there's nothing saying you have to plug in this first point either. You're more than welcome to say, I want to plug in this point. So y minus the y value equals slope times x minus the x value. That would be fine as well. You don't need to put both though. So I will just by default always use the first point. Okay, y'all have seen point slope before. Yes? But Algebra 1 you probably use slope-intercept more. Okay. I really just think that slope-intercept is, or point slope is easier, so don't feel like you have to do slope-intercept for me. Okay, so if we can do question 1, we should be able to do question 4, because it's just 2 points again. So either form I need slope, difference of the y's over the difference of the x's. Doesn't take long to figure out the slope is 5 over 2. Pick a point to plug the stuff into. Y minus the y value equals the slope times x minus the x value. And of course I'm not going to count that wrong, but it's also kind of silly to say minus 0, so I feel weird leaving that in my answer. So I'm going to highlight some stuff today. Most of the stuff I highlight is going to be on the front page, but I'm highlighting the things that are like formulas or things that you may have forgotten that I would encourage you to also jot on the top of your page. So if you don't remember what slope-intercept looks like, or point slope formula looks like, or the slope formula, I would include those to the top of your page. Okay, question 2 says we wanted to go through -1, 5, and it needs to be a horizontal line. So I don't have 2 points, so I can't just plug the points into the slope formula. I've got to figure out a different way to have slope. So what do we know about horizontal lines? Okay, they look like that. If you look out on the horizon, you're looking left to right. Okay, what about their slope? 0 because there's no rise. Okay, do you know what kind of equation they have? A number. Y equals a number.
Yeah.
So really, if you know this stuff, and I'm about to highlight it, the only way it goes through -1,5 and to be horizontal would be for it to be y equals 5. Like, that question can be that easy. Now, if you don't have as much of that memorized, I'll talk about how you can still discover it, but you still need to know most of this. And then on the next page, we'll also need to review, if we need to know about vertical lines or horizontal lines, then we certainly need to remember stuff about vertical lines. What does a vertical line look like? What is its slope? And what is its equation? All of that is going to make your life easier. The more you know, the more shortcuts you can take. So on question 2, if you can't just go straight to y equals 5 like I did, maybe you at least know the slope is 0, then you could say like these questions. Once I had the slope and a point, I could plug in the y value, the slope, and then the x value, but timesing by 0 makes all of that go to 0, and of course if you add the 5, you can see how it ends up being the same thing. It's just a lot quicker if you know that its equation is going to be y equals 0. You should still be able to stumble upon that equation as long as you know the slope is 0. Okay. So number 3 also doesn't give me 2 points, so I can't use slope formula. The lines are not vertical or horizontal, so they're not slopes that I have memorized. But it says that the slopes, or I want one that is perpendicular. So we need to review what it means to be perpendicular and parallel. So parallel lines never touch, and so the only way that they're never going to touch is if they rise or fall at the same rate. So same slope. What about perpendicular lines? You don't remember that one?
Is it the reciprocal?
It's like a slope that is
Okay, reciprocal is part of it, yes.
opposite.
Yes, opposite reciprocal or negative reciprocal. Some teachers say different there. I like to say opposite because they should have the opposite sign, and they need to be reciprocals. We did tons of reciprocals last semester, so I'm sure you're okay there. So before I even think about this stuff that's highlighted, if you want an equation that goes to this point, point slope says y minus the y value equals the slope times x minus the x value. Like, I've almost got my answer. I just need to know what is the slope to plug in. So if this guy has a slope of 4, that's positive. So opposite means it should have the opposite sign, negative. And reciprocal of 4 over 1 is 1 over 4. So if you want it to be perpendicular to that line, you need it to have a slope of -1/4. So I know you've heard these things before that I have highlighted, but do you remember them? I don't know. Some people will be yes and some people will be no, but you need to jot that on the top of your page if you don't remember. Okay, and then this would be a good time to kind of step back and see if you have any general questions or any detailed questions about 1 through 4, because all of these kind of fit together. Okay, then let's move on to question 5 and 6. And as I said, probably 80% of what we'll talk about today is just reviewing, but there's 2 things that I think might be different to you, and this is one of them: direct variation. It's not that direct variation is difficult. It's actually supposed to be taught in Algebra 1, but it's usually one of those things that if your teacher runs out of time teaching the stuff they're supposed to teach, that's usually one of the first things to go. So direct variation has a couple things that if you know about this line, it makes these no harder than the questions above. Direct variation is in the format y equals kx K is just a different name for slope, and we often call it the constant of variation. So if you look at question 6, the first part of question 6 says find the constant of variation. It's really just asking for the slope. And if it's a direct variation line, it's assumed that it goes through the origin. So there's an implied point given to you. So for question 5, come up with the equation of a direct variation line that goes through 3, 2. Technically, all you need is this last piece, because if you know it goes through 3, 2, and you know it goes through 0, 0, it's just like questions 1 and 4 above. 2 points. If nothing else, we can use the slope formula to find the slope. Plug in y1, plug in the slope, plug in x1 into point slope. Subtracting zeros, kind of silly. And so even if you technically didn't have that form memorized, your answer's still going to end up looking like that in the end anyway. And there's a little bit of patterns going on there, but I don't think it's worth trying to memorize any of those patterns. I think if you know what I have highlighted for you, you have enough information to get yourself to the answer. Okay, number 6 has 2 parts. Number 1, find the constant of variation. So really, what is K? But we know that that's the same thing as slope. And then part 2, find the value of y when x equals -2. Okay, so they tell me that this direct variation line goes through this point. But I also know, because it's a direct variation problem, it also goes through the origin. So that's just assumed. You're supposed to know that part too. So if I want to know the slope, it looks like I could just use the slope formula. Subtract the y's over subtract the x's. Let's see, dividing by 1/3 is the same thing as multiplying by 3. So there's the slope. There's the constant of variation. The work's no harder. It's just that you have to know those couple of things. You have to know what constant of variation is. Now I can use that in part 2, and I can say, okay, well, if the equation is supposed to look like this, and I just figured out K is -18, and you want me to solve for y when x is -2, I guess I'll just plug those things in and solve for y. 36. Okay, so I know that's different to you, so now would be probably a good time to kind of scan all of that, see if you have any questions, any clarification you think you might want. But you will get to practice it on worksheet 2, so if you're not getting the answers correct, you'll know to ask, and we can discuss another set of those. Okay, then on to the back page. The first, or the majority of it, is about graphing. So if you wanted to graph something like number 7, I guess you could make a t-chart. You could throw in random x values. You could solve for y. And if you do that enough times, you're going to figure out what the line looks like. I guess technically you only have to do it twice because it's a linear line. However, a needed skill that you're going to need on the bottom of this page anyway, most people prefer to switch this to slope-intercept. And to do that, you solve for y. So subtract the 2x, divide everything by -3. And kind of the nice thing about slope-intercept, and why you do so much slope-intercept in Algebra 1, is it's just easy to graph. Intercept That's the y-intercept. That's just a point on the graph. Slope, you can count rise over run to get a second point. Up 2, right 3. And you only need 2 points to define a linear line, so that's technically enough. But if you want your line to look good, you might do the rise over the run a couple more times. Give you more points to line up for. So you got options, but most people would solve it for y, put it in slope intercept, plot the y-intercept, count rise over run on the slope to get a second point, or a third point, or a fourth point, and then connect them. All right, how are we supposed to graph 8? Okay, so the key is here is to recognize that this is a vertical line. Now, I already highlighted that on the other page. So we know it's going to look like this, and it's got to hit where the x values are always 4. Well, yeah, we'll just pretend like my line's straight. It's close enough. So, very little work to be done, but make sure you know what you need to know about horizontal and vertical lines, so you can graph that. Okay, number 9 we're going to come back to. This is a piecewise function. We're actually planning on spending 1 full day on those, because these are especially important if you're doing calculus next year. The first 2 or 3 weeks of calculus, we do limits, and limits have lots of piecewise functions. So let's come back to that one. 10. This is asking you to remember what the absolute value of x looks like. That's a parent function. And then maybe apply a transformation rule where you have to shift it up, down, left, or right. Subtracting 1 from x shifts it right 1. And that will help us in the last question as well. So knowing that parent function absolute value of x and maybe shifting it up, down, left, or right. So okay, number 9 is a piecewise function, and piecewise functions are not nearly as difficult as sometimes students make them out to be, but to your credit, you just don't practice them as much in Algebra 2 as you probably should. So a piecewise function is just a function that's split up into multiple pieces. So sometimes it's going to be y equals -4. I know how to graph that. Sometimes it's going to be y equals 3x minus 2. And that's in slope intercept, so I could graph that. And sometimes it's y equals 2. And I can graph that. And that's the hardest part. Now, I'm not finished. This isn't my function. This can't be a function. It doesn't pass the vertical line test. I've got to use these restrictions over here. So when I said sometimes it's y equals -4, I graphed the whole thing. I said it went forever left and forever right. Well, my answer better not do that. My answer better only have x values that are equal to -2, so that's a closed circle, or less than -2. But it shouldn't have any of that stuff to the right. So I erased it away. Same thing with the 3x minus 2. I have it going forever in both directions, but really it should only exist between -2 and 1. So notice it doesn't include -2, so that should be an open circle. And it should be bigger than that, but smaller than 1. 1 includes it, so 1 should have a filled in circle. And then it should be all of the stuff in between those x values. But nothing to the left of that one, nothing to the right of that one. Only between -2 and 1 should that function exist, or that piece of the function exist. So I'm really just erasing parts of my answer here. Okay, last part, it's y equals 2, but only when x is greater than 1. So not equal to 1, open circle, greater than 1 would be to the right, so I shouldn't keep anything on the left. So it's really like graphing 3 linear lines and just keeping part of this one, part of this one, and part of this one. Also, you don't have to do this, but I think it's kind of a good way to help you check. This is supposed to be a function, f of x. That's implying that it's a function. Something's not a function if it doesn't pass the vertical line test. So notice, if I draw any vertical line, including here, it only hits in one place, because it hits here, not there. It hits here, but not there. And if the vertical line test is checking out, then I'm sure it's a function. So if for some reason you thought your answer, what you thought the answer would be, was not passing the vertical line test, then you would know, hopefully you would know something's off. Okay, so we'll have you practice one of those on worksheet 2, but again, I think our plan is to spend a whole day on that. So number 7, how I switch this to slope-intercept form is how I would do question 11. Just because I don't like to use slope-intercept form, I still need to know what it looks like. It does have some benefits. So it basically amounts to solving for y. Subtract the 2x over, divide both sides by -5, and get it in mx plus b format. Okay with that? Okay, and so I said there's probably 2 things. One was the direct variation I don't think you've seen before. And then the last thing, absolute value functions like this can be rewritten into a piecewise function. In fact, mathematically, that's how they're defined. So before I show you this one, because I'd kind of just be telling you how to get the answer, and I don't think you'd necessarily understand why it works that way. Over to the side, let's do a more basic one. The classic example is just doing the absolute value of x. Absolute value of x is not a linear function because it turns, like it switches direction at some point. Linear lines go forever in one direction. They keep the same slope. There's no curvature to them. But I can think of it in pieces. So right here, this piece is linear. What does this equation look like? Okay. So it's the same as the thing under the absolute value sign. So for us in question 12, one of our equations is going to be 3x minus 1, the thing that's under the absolute value sign. Okay. The other piece is that. What does that equation look like? Okay, which is just the exact opposite of what's under the absolute value sign. So for us up here, the exact opposite would be that multiplied by -1. Okay, now we got to think about the restrictions because we don't want forever on both of them. So on this one, well, the main thing I'm interested in is this point right here. Where are they handing off from one function to the next? And it's handing off at 0. So the one with the positive slope is when x is greater than 0, and the one with the negative slope is when x is less than 0. 0, x equals 0 is kind of the handoff spot on this one. Now, if I don't include either one of these, my graph would have a hole in it there. It wouldn't exist. So you can either include it here or you can include it here, but you need to include it in one of the two, but not both. You don't want to double dip on it, but it doesn't matter which one it goes with. So my goal here is now I got to figure out, well, kind of what does this graph look like so I know when it's switching from this function to this function. That's going to be an absolute value function, so I know it's going to look like a V. I really don't care about any of this other stuff. The point that was really important was right here, the x-intercept, where it switched places. And so you can make a table and you can do as many points as you want, but the one I'm really interested in is when y is 0. So when y is 0, looks like x would be 1/3. There's 1/3. I don't know exactly what the rest of it looks like, but I know it's a V shape. I'm not interested in that. I care about this 1/3. That's where it's handing off. Okay, well, it makes a difference where you point the sign. You don't want to use the wrong part of each one of these. So what I would look at is I would say this piece has a positive slope, just like this piece does, and it exists when x is bigger than 1/3. This piece has a negative slope, just like this one has a negative slope, and it exists when x is less than 1/3. And then the only other thing we need to do is we need to make sure we include one of these so that we actually hit this point, and it doesn't matter which one you include. Either one's fine, because they should both hit it. So it's kind of formulaic how to come up with the answers. One of your functions comes from what's under the absolute value function. The other function is the opposite, so multiplying it by a negative. We can see it, it's a lot easier to see here than it is here, but that's how that would work. And then you got to make sure that you keep the right part of each line. So think about where they're handing off, which is the x-intercept. Very easy to see here because we have this graph memorized. But this one I didn't know where it was, but I solved when y equals 0. I could tell x had to be 1/3. So 1/3 is where it was switching off. I knew I wanted the right side of this one because I wanted the positive slope to be after that, and I wanted the left side of this one because it's the one with the negative slope, and it exists to the left of 1/3. So that's how you go about piecing those together. So I'd say, I don't know if it's really that much harder, but it does take a little bit of practice, but I know it is new to you. So any questions on 12 that you already see you need to ask? Okay, then again, you should really figure it out by the worksheet too, if you have it down or not.